Hi all, and welcome back to the next episode of the Crazy Small Computer video series. In the last episode I'd got the ALU working and tested, and now I'm bringing in the two registers, the A register and B register. So as we saw last time, we needed two 4-bit inputs for the ALU, and I've wired up 4 lines down to the A register and 4 lines down to the B register. But before I show you it in action, let's just have a look at what we've done. I'll go back to the schematic. Here's our ALU with our 4 lines 0 to 3 going down to the B register, down here, and 4, 5, 6, 7 on the ALU going down to the A register. And I've got a spot to put the LEDs for the output of the A and a spot for the LEDs for the B register. Okay, but let's talk about what type of chips we're using for these two. And we're using the 74LS161 chip for our A and B registers. The nice thing about this chip is that it's both a 4-bit register, and we can also use it as a 4-bit counter, which is really excellent for when we get to doing the program counter. But for now, we're just going to use it as a register. So this time it's a sequential circuit. We need to give it a clock pulse, and it will load the incoming value from one side into the register, which will then be the output. So what do we need to do? We need to send in a clock pulse, and on the rising edge it will be loaded, and the value to be loaded will come in on the lines D0 to D3. Once the register value is loaded, then the output will change, and the output will come out on lines Q0 to Q3. One more thing we need, and that's the line PE, which is active low. When that line goes low, we can load from left to right. If that line stays high, it doesn't matter what the clock pulse is doing, nothing on the left is loaded into the register, and it won't be visible on the right hand side. Alright, so with that out of the road, let's bring the CPU back in and show some testing. Alright, so now we have the CPU back and powered up, and I'm using the monostable clock pulse, and I've got the lines out to set the value of the two registers. So 4 wires out for the A register down to here, 4 wires for the B register down to here. Alright, now at the moment all of the lines coming in are zeros, so no matter what I do, none of the registers are going to get loaded. But if I just quickly change this one to a 1, then we've loaded a 1 into the A register. Now it's a bit annoying because we've got low bits going to high bits here, and low bits going to high bits here, but when we get over to the ALU, and we're doing addition at the moment, we've got the low bit on the right. So that threw me this morning when I was putting it together. So at the moment we're doing 1 plus 0, and we get the answer 1. But if I now change, say, the B register to the number 2 and press the clock pulse, we now have 0 and 2, so that's 2 on the B register, 1 on the A register. Remember, these are upside down, and so now we've got 2 plus 1 is 3 out on the result. And let's just quickly, let's make a high bit coming in. So we'll change the B register to have an 8 as well. So we've got 8 for 2, so that's 10, plus 1. And so therefore the output is 8 for 2, 1. So 8 plus 2 plus 1 is 11. So it does look like it's working. Let's just do one more change. Let's put a couple of wires in and see what actually happens. Alright, so I'm not sure if you can see that. So I've got 4 plus 2 plus 1, what's that, 7 over on that one, and I've got 8 plus 2 is 10, so that should be 7 plus 10, 17. Of course we can't store 17 in a 4-bit value, so we're getting the number 1 here, and I haven't wired up the flags LEDs, but if I did, you'd see that we'd actually have a carry bit coming out on the flags lines as well. Excellent. So with a couple of 74LS161s, we've now got two 4-bit registers going into our ALU.